Circle the odd numbers in each row. Five is odd. 7 is odd. 3 is odd. 9 is odd. 11 is odd. 1 is odd. 7 is odd. 13 is odd. 15 is odd. 17 is odd. 5 is odd. 11 is odd. 9 is odd. 13 is odd. 17 is odd. 19 is odd. And 3 is odd. And they're odd because they can only be divided by 1 and the specific number, except
cannot be divided evenly by 2.
Except other than 9. 9 is a number that can be divided by 3, but it is still odd. But on this page, all of these are prime numbers. That means that only they can be divided by 1, and it comes up that number. So 5 doesn't divide into anything else except 1. And the same goes for 7, because it will always be 7. There's nothing else that's going to make it less than 7 or less than 3. But 9, if you divide 9 by 3, you get 3. And 11, you have to divide it by, divide by 1, it's still 11. So yeah. Okay, so the next one is circle the even numbers in each row. Six is even. 2 is even. 4 is even. 8 is even. And 12 is even. 8 is even. 10 is even. 6 is even. 12 is even. 16 is even. 14 is even. 16 is even. 12 is even. 18 is even. 4 is even. And 8 is even. Now these numbers can be divided into something and turn out into a different number. Such as 6, if you divide 2 by 6, you get 3. If you divide 2 by 2, you get 1. If you divide 2 by 4, you get 2. If you divide 2 by 8, you get 4. If you divide 2 by 12, you get 6. If you divide 2 by 8, you get 4. If you divide 10 by 2, you get 5. If you divide 2 by 6, you get 3. If you divide 2 by 12, you get 6. If you divide 2 by 16, you get 8. If you divide 2 by 14, you get 7. If you divide 2 by 16, you get 8. If you divide 2 by 12, you get 6. If you divide 2 by 18, you get 9. If you divide 2 by 4, you get 2. And 2 divided by 8, you get 4. And so again, these are even numbers. And again, with the odd numbers, such as 9, if you divide 9 by 3, you get 3. But 11 is odd, is prime. It doesn't divide anything into anything else. 7, that's the lowest number. It cannot be divided into anything. 3 cannot be divided into anything. 13 cannot be divided into anything. And again, 9 can be, and you would get 3. 5 can't be divided into anything, and 19 cannot be divided into anything other than 1. So when I say into anything other than 1, again, 9 divided by 3 is 3. 11 is just 11, and 7.
And how many
Okay,
times you divide it?
so in this video, I might have said it wrong in explaining how these even numbers are divisible by a specific number. So such as 8 divided by 4 will give you 2. It will equal 2. Now 2 divided by 8 would equal 0.25. It becomes a decimal. So the same thing is such as in these prime numbers, they would become decimals if we were to divide it by a certain number. But we're thinking about whole numbers. Whole numbers are on the number line 1 through infinity. Okay, so like when I say 1 through infinity, I mean 1, really 0 whole number, but 1 through infinity. That means it just goes on forever on the number line. So let's do the number line. Okay, so this is a number line, okay? And we're gonna start our whole numbers at 0. And let's say for this number line, we're gonna just write them to 10. Okay? So these are whole numbers. So 0 to 10, okay? Now, let's do another number line. Okay, I went ahead and I decided to draw another number line from 0 to 20. But from this number line, okay, so even numbers are 0, 2, 4, 6, 8, and 10. And if we were to continue, it would be 12, 14, 16, 18, and 20. But for the 1 through 10 or 0 to 10, those are the even. The odd are 1, 3, 5, 7, 9. And continuing to 20, 11, 13, 15, 17, 19. Okay, so like when we do our timetables, let's count by 2. So it would be, for the sake of the simple one, from 0 to 10, we starting out at 2 and we're counting by 2s, 2, 4, 6, 8, and 10. Okay, now continuing from 20 by 2, 12, 14, 16, 18, and 20. If we wanted to count by 4s, it would, from the 0 to the 10 number line, it would be 4, 8. Okay, now if we go from the 20, starting from 8, it would be 8, 12, 16, and then 20. If we wanted to count by 5s, starting again at the simple number line, 5, 10. Okay, it's 5 jumps. Okay, so continuing from 10, 15, 20. Okay, so I've done 3 different number lines. This first one, we would count by 2s. So starting from 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 28, 32, 34, and 36. And these are all even numbers because they're divisible by 2. Okay, so counting by 4s, starting at 0, we would have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, and 64. Next, counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, and 80. Okay, so I have a couple of, or a few, or several different questions as far as multiplication goes. And so I'm going to use the timetables sheet to help with the solution. You know, so again, you need to know how to do this on your own, but in the case of the video, I'm going to teach you how to use your table sheet. So again, so we all think about the numbers, whole numbers. We talked about odd numbers and even numbers, odd and even numbers. So if we do the 5s, we know that that's odd, even, odd, even, odd, even, and so on. In the case of 4s, these are even numbers and 2s are even. Okay, so we're gonna do multiplication. And so we see 7 times 5, and looking on the number, the multiplication table, 7, we look for 7, and then we go down to 5, it's 35. Okay, so 2 times 3, we look for 2 and go down 3 times, it's 6. 6 times 5, 6, then we go 5, 30. 9 times 5, look for 9, and then go down 5 times, 45. Two times 8, 2, going down 8 times, 16. 9 times 4, 9 to 4 times 36. 1 times 2, 1 to 2 is 2. 0 times 0. We don't have that on the multiplication table, but we know that that is 0. Okay. 1 times 0 is going to be 0. 4 times 2, 4 to 2, 8. 5 times 5, 5 times 5 is 25. 9 times 0 is 0. And that's as far as it goes for multiplication. Now division for these numbers or similar numbers. Okay, so I'm gonna try to explain division using the table, the multiplication table. So here we have 5 divided by 25. So, okay, so if we're using the multiplication, if we don't know our timetables yet, we see 5 here, and then we see 25 here. So that's basically equal to 5, okay? So we're gonna put 5 here, okay, and then we're done. 4 divided by 16. We find 4, and then we see 16, and again, that's equal to 4. And so we're gonna go ahead and put 4 here, and we're done. And so maybe I should write it out, because you need to write it out. So that is 0, and then it's 5. That's 16, 0, and so we're done. There's no remainder, because they are division numbers. When we talked again about the odds and evens, let me get that page. Odds and evens. Like if we were to divide 5 by 1, it would be 5, and so on. But then there are numbers that we can divide these prime numbers by that would give us a decimal. Okay, so let's go back to this right here. These should all be whole numbers. So 7 divided by 21. We look for 7, and then we see 21. And so we see 3 makes 21. And so if we want to do it this way, 21, and we know that's 3, and then the 0. Okay. 9 divided by 81. We see 9 here, and then we see 81, and then we see that's even. And so 81, and then 9. Okay. 6 divided by 18. We find 6, and then we see 18, and so it's 3. So we can go 18 goes 3 times. 6 divided by 54. Here's 6, here's 54, there is 9. So 9, 54, and then 0. 3 divided by 27. Here's 3. There's 27. It goes in 9 times. So 9 and then 27. Okay. 9 divided by 72. Here we have 9. We found 72. 8 times. Okay. 7 divided by 49. 7, and then we find 49, and we see that's even. 7. 3 divided by 24. We look for 3. We found 24. 8. 4 divided by 28. Find 4. Here's 28. 7 times. 7. 8. Okay. 9 divided by 36. We have 9, and here's 36. 4 times. 4 times. 36. 0. 2 divided by 14. So we look for 2, and we found 14, and there's 7. So 14, 7. 3 divided by 6. 3, and then here's 6. There's 18. How did I do that? I didn't do that right. I'm sorry. 3, and then 6 is 2. 8 divided by 16. 8, and here's 16. 2. 3 divided by 35. 7 divided by 35. 7, and here's 35. 5. 5 divided by 15. 5 and 15, 3. 7 divided by 42. 7 and then 42, 6 times. 9 divided by 45. 9, 45, 5 times. 2 divided by 2. 1 time. Okay. 7 divided by 63. 7. 63. 9. Okay, so if we were to do it backwards, how we get our multiplication, we would say 5 times 5 is 25. 4 times 4 is 16. 3 times 7 is 21. 9 times 9 is 81. 3 times 6 is 18. 9 times 6 is 54. 9 times 3 is 27. 8 times 9 is 72. 7 times 7 is 49. 8 times 3 is 24. 7 times 4 is 28. 4 times 9 is 36. 7 times 2 is 14. 2 times 3 is 6. 2 times 8 is 16. 5 times 7 is 35. 3 times 5 is 15. 6 times 7 is 49. 5 times 9 is 45. 1 times 2 is 2. 9 times 7 is 63. Okay. In the case of a number here, we have, when we're talking about fractions, okay, here's a line, and here is a number, like say 1 to 10, or on the bottom, we have another number, and say that could be 1 to 10. This is considered a math problem. So you'll see something like 1 divided by, or over 2 is not divided by, but, so this is considered a fraction. This is this, okay? And so when we consider division, if we were to say 1 divided by 2, we know that 1 goes into 2 times. So 1 and then 2. That. Okay. Or if we look at, if we make a picture, here's a circle. This is the whole, okay? This 1, okay? So this is the numerator. Okay? The top number is the numerator. And then the bottom number is called the denominator. Okay, so this 1, right, this 1, and it's 2 parts. 1, 2, okay? And so in the case of the picture, what the picture is showing is one side is shaded. Okay, so 1/2 is shaded. Okay. So in the case of, let's say, if it was
okay, let me
2 over 2 is the fraction, and so we
let me see what
I think so right here, and then that would be, all of it would be shaded, because that's 1. That equals 1. Okay, so I have a couple of pie pieces that I have cut out or drawn out. Okay, so to try to explain this well, okay, so this is 1, okay, but because we've divided it and we're talking about fractions, here's 1 and then 2, okay, and so if we were to say shade in a part of this whole, okay, that would leave us with 1/2 not being shaded and the other half being shaded. So that is considered 1/2, okay? All right, so here's again a whole, and but it's parts 1, 2, 3, and 4, okay? So again, with the fraction, 1 over 4, because there's 4 pieces out of the whole, okay? And if we were to shade, I'm trying to think, say we wanted to shade this in, because this is what the fraction is. We've broken them up into 4 different pieces. And so if I were to shade in that piece, then that would be, okay.
So it'd be
all right,
better
so, okay, we're gonna start it this way. Okay, so here's 1 again. So how many pizza slices are there? Now start right here. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so there's 8 pizza slices out of the whole, so it would be 1/8. Okay, with this, how many pizza slices from the whole? So we have 1/2, okay, because we have 1 and 2. Okay. And here we go again. Here's 1 pizza slice. It's cut up into 4 pieces. 1, 2, 3, 4. And there we have 1/4. Okay. And here we are here. 1, 2, 3, 4, 5, 6, 7, and 8. Again, it's 1/8. And then here we have 1, 2, and 3. So 1/3, or 1, it's 3 slices. And here again we have 1, 2, 3, 4, 5, 6, 7, and 8, and then 9. Okay, it should be 10. It should be 10. So let's draw another for this one. This one should be 10. So it would be 1/10. Okay. Okay, for the sake of this video, all right, we're just gonna draw a picture, and then we're gonna see what the fraction is, how many pieces is in the whole. So for this one right here, this is 1 number, and there's 2 pieces. So that's 1/2. Here's 1 piece, or 1 whole divided, or and broken up into 4 pieces. So we have 1/4. Again, a whole broken up into 8 pieces, 1/8. A whole, which is 1, broken up into 3 pieces, is 1/3. A whole broken up into 10 pieces is 1/10. 1 whole broken up into 12 pieces is 1/12. And a whole broken up into 6 pieces is 1/6. So in the case of being able to reduce a number, here's a fraction, and we want to reduce it. And since these are relatively simple fractions, we see it's 2/6. Now, if we were to make a whole, right, and then we know that there's 6 pieces, so that's 4, and so that's 6. So 1, 2, 3, 4, 5, and 6. okay? And so 2 of those pieces have been shaded, okay? And that's how you get the 2, 6. But in the case of reducing it, we know it would be considered 1/3. Okay. All right. So to reduce, it's 1/3. Okay. So, and it, as far as the picture goes, it would be 1 whole broken up into 3 pieces. And there you go. That means that that can be reduced. It's able to reduce to a lower number because it's 2, 6, and then it could be reduced to 1/3. Okay, and that would just be 1, and then that would be 1/3. Okay, as far as 3, 6, here we go. 1 whole, divide up into 6 pieces. All right, 1, 2, 3, 4, 5, 6, and then we were to shade in 3. Okay, that would be 3, 6, but it can be divided lower, so it can be reduced to 2/3. It can be reduced to 2/3, and so again, here we have a whole broken up into 3 pieces, and so 1, 2. Okay. Reducing 4/6. Okay, again, if we were to do the whole piece broken up into 6 pieces, so again, that's like 1, 2, 3, 4. That's 4, 6. But then we're trying to reduce it, and then it reduces down to 2/3. Okay. And again, with this one here, and that piece would be like this again. It would be just like this again. And then this one right here, the same thing. Whole, but broken up into 8 pieces. 4. Okay. So we know that's 1, 2, 3, 4, 5, 6, 7, and 8. And so 6 of those pieces are shaded in. Okay. But we know that we can reduce it. So 6 is 6 and 8. Then we have 3/4. And if we were to draw a picture, it would be like this. 1, 2, and 3. So it would be 3/4. Okay, this one again, here we are. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 1, 2, 3, 4, 5, 6 are shaded in, but we can reduce. So that reduces down to 3/5. And we have 5 slices. 1, 2, 3. That would be that. And then 3/6, or 3/6. Here's the whole. 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. And then here we just shade 3/6, but it could be reduced to 1/3, or no, 1/2, right? Yeah, 1/2. And so here we are here, and then 1, 2, and then half of that. And that is how we do this homework. I'm going to make it a homework assignment, so to learn how to set up and learn fractions.